I have you loud and clear.
Hello. Welcome. Science.
And that is to say,
physics, medicine, nature,
or
space, time,
the brain,
life, the universe.
Hello, this week, Humanity 2.0. Can we use genetics, drugs and technology to become superhuman?
Plus, in the news, do men and women really think differently? Why what we call a kilogram is changing? And researchers uncover an animal that can talk about the past. I'm Georgia Mills.
I'm Chris Smith, and this is The Naked Scientist.
The Naked Scientist podcast is powered by ukfast.co.uk.
First up, with rising global temperatures, heat waves are becoming more frequent and more intense. But what impact is this having on the plants and insects all around us? As the temperature of our planet goes up, biodiversity tends to fall, but researchers have been stumped as to why. Now, a team at the University of East Anglia have found that, just like tight pants are bad for boys, heat waves can compromise sperm counts in insects. Izzy Clark heard how from Matt Gage.
So although there's been a lot of research looking at warm-blooded species and how heat can impact on male fertility and sperm function, there's been very little work looking at cold-blooded species like insects, for example, which we thought was quite a knowledge gap because most of biodiversity on our planet is cold-blooded. They may even be more sensitive to environmental temperature change because their own core body temperature will change as the external thermal environment changes as well.
OK, so what did you find looking at these cold-blooded species?
We were basically interested in how experimentally induced heatwave conditions impacted on reproductive performance and reproductive biology. We chose a beetle because, first of all, it's an insect. About a quarter of insects are beetles. So what we did was we quite simply took adult male and female beetles and we exposed them to simulated heatwave conditions. And our heatwave conditions were those that are widely accepted as a definition of a heatwave, which is when the normal temperature rises by 5 degrees for 5 days. And then what we found was that male fertility or male reproductive output declined markedly with heatwave exposure. So one heatwave about halved a male's reproductive performance. And when we gave males a second heat wave, they basically became sterile.
What about female beetles? What did you see there?
So the females were in themselves resistant to heat waves. So if you heat wave a female beetle and then mate her to a male who hasn't been heat waved, she's fine. Her reproductive output is exactly the same as if she's never experienced a heat wave. But if you mate the female, so she's got mature inseminated sperm in her sperm storage organs, which most female insects have, then she suffers as a consequence of heat waves. So somehow the heat waves are damaging the sperm that she has stored inside her, and then we see about a 30% decline in a female's subsequent fertility.
Oh, I see. So they'll mate with a male, they store that sperm and use it as and when they like, but if they experience a heat wave, the female isn't really affected, but that sperm that she's carrying is.
That's right. But what we also found was a transgenerational impact of heat waves. So if you're an offspring born from a dad who experienced a heat wave, or indeed from a sperm, we found a lifespan cut in those offspring. So they lived about 20% shorter than offspring whose dads or sperm never experienced a heat wave. And if you're a son from a dad or a sperm that experienced a heat wave, your reproductive potential also was reduced.
Oh gosh. And do you know what is actually going on in that reproductive biology to cause this effect?
We don't at the moment, but our prime suspect is DNA damage. We know that heat can damage DNA inside sperm, and we know that sperm that have damaged DNA also have fertility and indeed pregnancy problems, for example, in humans. But we haven't actually shown yet what the mechanism is that this transgenerational damage occurs by.
And what about the impact? If we're seeing these reproductive issues and climate change affecting male fertility, what impact could that have?
Well, I guess if you're thinking from a biodiversity perspective, it could be a pretty big impact because if you can't reproduce, your population viability is not very good. So we've shown under control conditions, that sperm sensitivity could lead to the population declines we're seeing in the natural environment. But we really want to pin that down more closely, and we're planning to do that both in the lab at a population level and maybe to try and take that to the field as well and have a look at it in insects under more field relevant conditions. And we'd like to know whether populations can adapt evolutionarily to changes in the climate and how quickly they can adapt. And of course, we'd really like to understand what the mechanism that's leading to that transgenerational damage, because that could have relevance for a lot of species, including our own.
Some very interesting and concerning findings there. That was Matt Gage from the University of East Anglia, and that study has just been published in Nature Communications.
The 1992 book Men Are From Mars, Women Are From Venus was a bestseller for US author John Gray. Now, admittedly, it was all about relationships, but at its core was the claim that males and females think differently. Putting that another way, psychologists have suggested in two theories that women tend to be better empathisers, men tend to be better systemisers, and autistic people tend to have a brain that's an extreme example of the male type. But those claims were based on studies of fewer than 100 people. So now scientists have repeated the analysis on a very large sample. But what did they find? Varun Warrior is one of the authors on the new study.
These two theories look at how men and women think about certain things. So the first theory is called the empathizing, systemizing theory of sex differences. And according to this theory, we can look at two particular domains: empathy, which is the ability to recognize what someone is thinking or feeling, and the other one is called systemizing, identifying and recognizing patterns. What this theory suggests is that men on average are better than women on systemizing, and women on average are better on empathizing. The second theory deals with autistic individuals. Autism is a neurodevelopmental condition where individuals typically have difficulties in social interactions and unusually restricted interests. This theory, which is called the extreme male brain theory of autism, suggests that autistic individuals tend to be better at systemizing and poor at empathy compared to the typical population.
So what did you set out to test?
So the previous studies had examined these two theories using relatively small sample sizes. We wanted to see how robust these results are. So we got data from approximately 650,000 individuals, which also included data from 36,000 individuals who had been diagnosed with autism. And all of them filled out these two measures of empathy and systemizing.
Can you just explain, how do you work out how empathic I am? How do you work out to what extent I systemize?
One way is using a self-report measure, which asks questions like, how much do you agree or disagree with particular statements? So statements include, people have often told me that what I say is rude. In this particular study, we used 10 such questions. Similarly, we used 10 such questions which map self-reported systemizing. Questions like, I often notice small details that other people don't.
And you're now bringing to the party enormous numbers of people that you've been able to study. You say, it's more than 650,000 who've been studied, isn't it? What trends emerge?
Well, what we see is that on average, typical men do score slightly higher, but statistically significantly higher than typical women on the self-report measure of systemizing. And typical women on average score slightly higher than typical men on the self-report measure of empathy. When we dig in a bit deeper and look at autistic individuals, we see that on average, autistic individuals, regardless of their sex, tend to score higher on this test of systemizing and tend to score slightly lower on this measure of empathy compared to the typical population.
Have you broken it down by age? Is this something that people grow into from a child growing up? Or is it an innate thing that's present from the minute an individual's born as a boy or a girl, they're going to develop into these traits?
Yeah, so we looked at some sort of correlates of age with scores on these tests. We know that both empathy and systemizing are partly genetic, so there is some innate component to it. But this is only a fraction, so genetics explain approximately a third of the total variance in both systemizing and empathy. So there is considerable other factors that might contribute to, typical variance in empathy and systemizing, and we don't really know what these factors are. It is very likely that, environmental factors such as societal norms do indeed shape empathy and systemizing, and certainly people's awareness of how empathetic or systemizing they are.
What are the implications of this now? Because this basically adds additional weight to the theory you came up with 20 years ago, but where does it leave us? Where next?
Going forward, we also need to understand where these typical sex differences emerge. Do they come from environmental factors? If they are from environmental factors, what policies can we have in place to sort of minimize these sort of sex differences? How can we sort of encourage more women into STEM? How can we have policies in place which encourage more people into fields of systemizing? And equally, how can we encourage more men to be more empathetic? So that's something that we really need to dive into.
It's fascinating, that, isn't it? Varun Warrior there. He's based at the University of Cambridge, and the paper that contains the results he was discussing, if you want to give it a look, has just come out in the journal PNAS.
This is The Naked Scientist with me, Georgia Mills, and with Chris Smith. Still to come on the show, orangutans are found to possess a cornerstone for the basis of language, and humanity 2.0. Can we become superhuman? But first, the meat industry is one of the worst producers of greenhouse gases globally. And what feeds this industry is that the average Westerner eats about their own body weight in meat every year. And although some people have cut their consumption or gone vegetarian to reduce their impact, most people remain staunch carnivores. So can science help? With us is Mark Cotter. He's from Cambridge University and is PI of Cambridge spin-out Elpis Biomed. And one of their technologies may be able to help. So what have you done here? What's new here?
Essentially, in my academic lab, we generated a new approach of making very consistent batches of cells.
Right, and what has that got to do with the meat industry?
Well, I didn't know until recently. Our view was to create cells that we can use to study human diseases. And one of the cells that we generated, really as a proof of principle, was a muscle cell. So some individuals who are interested in cultured meat thought this might be applicable to their problem, which is basically trying to create muscle and fat.
Right, which is what you would find in your lovely burger.
That's correct.
So you're taking the cow, well, not out of the equation, but the growing it, chopping it up and eating it bit. You're sort of taking out the middleman and taking stem cells and hopefully turning that into a burger. So how would that work?
So basically, we treat stem cells as the hardware. The analogy is really a computer. If you run a new program on a computer, you get a new function. If you run a new program in a cell, you can switch the identity of that cell into a new cell type. The little contribution that we made was to make this a very robust process. So we can turn all stem cells in a culture into a muscle or a fat or a neuron. And what we did is we're using gene editing technology like CRISPRs to bury the program in the DNA of the cell, and then once we want, we can turn it on and the entire population of cells will switch into a new cell type.
Do you think people will take this up as a new form of meat eating?
From my own experience, it was a very alien concept to me. But to be honest, it makes such a lot of sense. First, there's the ethics. We grow a cow, and a cow really is a complex organism which behaves a little bit like us as well. And what you do at the end is you chop it up and you just take the muscle. So I think that's quite barbaric, to be honest. The other thing is it has health implications. You can actually optimize the meat so that you can take out some of the fatty acids that might be damaging you, and you can get rid of a lot of the antibiotics that are currently used for farming. And the third factor, of course, are the environmental issues. It takes a lot of energy to raise a cow and then harvest it.
Will it scale, though, Mark? Can you grow enough cells to feed 7.5 billion people and possibly 10 billion by 2050? It sounds like a tall order.
You definitely are right. The scale-up will be the biggest challenge there. But if you think about the base population that we use, which are stem cells, they really grow incredibly fast. And so if you put them into the right context, the models that I've seen suggest that you could do that. And in fact, for example, if you wanted to go to Mars, it's the only option to have some meat.
Unless you resort to cannibalism, of course.
Speaking of which, would it work for any animal in theory?
Yes. If you know the transcriptional program that controls a muscle or a fat cell in that species, it should be perfectly achievable.
When do you think we might see this in the shops? Could you put a guess on how long it might take?
I don't know. I think their ambition is to create the first burgers within 3-4 years. And of course, then the real challenges of scale will kick in.
Lovely. Well, as someone who's often called the world's worst vegetarian, I really look forward to this. Thank you very much, Mark Cotter from Cambridge University and Elpis Biomed.
Well, speaking of meat, the last time you were actually weighing out your pork chops, did you spare a thought for what we call a kilogram and why a kilo is actually what it is? Well, you probably didn't, because it hasn't changed for more than a century, actually. A kilo, for those not in the know, is actually the weight that corresponds to a big lump of metal that's sitting in London. And that's a clone of a similar object that's sitting in Paris. But now, scientists have been voting at a conference to bring the kilo into the 21st century and redefine how we measure it. Adam Murphy's been weighing up why and how.
It's important to be able to weigh things accurately, from baking cakes properly to the minute amounts required to get drug doses right. But we all need to be talking about the same thing. My kilogram has to be the same as your kilogram, or one of us is getting a terrible cake, or not enough medicine. The standards were decided in the 19th century in France, something for us all to agree on. Initially, 1 kilogram was the same as 1 litre of water. But the density of water changes with temperature, with pressure, with purity. So we came up with a different solution.
We've had the kilogram for a long time. The UK standard of the kilogram, number 18, was given to us in 1889.
That is Purdy Williams, assistant researcher at the National Physical Laboratory, where they keep one of the UK's kilograms. Lumps of metal that tell every weighing scales in the UK and Ireland what 1 kilogram is supposed to be.
And it's been working incredibly well. It's an amazing thing. But it is a single point of failure in the system. Also, we need to make sure that the original kilogram IPK, we need to make sure that's stable.
That's right, also known as Le Grand K, the international prototype kilogram is a cylinder of platinum iridium, about the size of a golf ball that's sitting in a vault in Paris. And it is 1 kilogram. And it's what all national kilograms like NPL's kilogram 18 take their cues from on what a kilogram is. So if I could get into that vault and say, hack a bit off or eat a bit, I would change what 1 kilogram was, how it was defined. I could invalidate every scale in the world. But the thing is, isn't it going to change with time?
Yes, so we believe the kilogram is changing over time, but we don't know by how much. IPK could be changing and gaining mass, and ours are all staying the same. We can't accurately see what's going on. So with the redefinition, we'll be able to have a better idea of what's going on with the mass scale. And also, it will be changed to a constant, and that can't change.
We're changing it hopefully this week. What are we changing it to?
So the new definition will be based on Planck constant.
Planck's constant is a number used in quantum physics. It's a 0, point, 34 more zeros, and a 6. It's incredibly small.
And this will be done using a Kibble balance. Basically, it's making an electric kilogram. So we're balancing out the force from the kilogram with an electric force. So its main concept is a magnet and a coil within the magnetic field. Once you pass a current through the coil, it produces a force and moves the platform up and down. And using the Planck constant, we can get mass from that.
And is our whole world about to tilt on its axis? Is everything going to change with this vote?
We've worked incredibly hard to make sure that the general public and end users don't see any change. A kilogram's a kilogram. It's just going to be defined differently.
And at the end of the day, why does this matter?
Measurement is so incredibly important. Everything can be measured. So we need to be as accurate as possible with the way we measure things and how we define things. People have been obsessed with measurement since the beginning of time. In ancient Egypt, they used to use the cubit, which was the length of the pharaoh's elbow to the end of his fingers. And that was how they did measurement. Even back then, they still were worried about things not fitting together or being scammed with how many seeds they're buying. We're just getting better at defining things.
Safe to say then that this is quite massive news. Wah wah. That was Purdy Williams from the National Physical Laboratory speaking with Adam Murphy.
I'm not going to comment on that. You're going to need megatons to measure the number of groans that are probably issuing from the audience right now, having heard that, Georgia. Now, the ability to discuss what happened yesterday or even last week is a subtle but really important cornerstone of language. But we don't know when or how this ability to react to something historical actually came about. But this week, scientists announced that they've discovered that one of our closest relatives also has this ability. And Georgia has been to the jungle to find out which one.
If you went down to the jungles of deepest, darkest Sumatra, what might you see? A shun bear? A pygmy elephant? Or perhaps a scientist crawling around under a stripy blanket, pretending to be a tiger? That's exactly what Adrian Lamira and his team at the University of St Andrews were doing. But I promise you, there is a reason. They were trying to find out more about perhaps Sumatra's most famous inhabitant, and our close cousin, the orangutan.
I'm looking at orangutan calls as living models of the precursor system of language. Language fundamentally transformed how our species transmits information and knowledge, but we have very little clues of how did this happen, how did such a new, powerful system emerge within our own lineage. Orangutans provide a really interesting case where we can go back and use their vocal behavior as models for what may have happened within our own lineage.
So Adriano and his team went on a fact-finding mission to Borneo and Sumatra to find out what kinds of calls the orangutans make. But there's only one problem. Orangutans aren't all that chatty.
I've spent many days with the microphone over my head waiting for them to say something, and I would go back to camp with no recording to speak of.
What to do? The team had an idea. What if they could get them to make an alarm call by showing them what appeared to be one of their predators, like a tiger or a leopard?
Yes, so typically it was me walking on all fours, and then we had sheets covering, and then it was the pattern of the sheets that differed between different types of predator that we wanted to simulate. And, I was the lead author, so I had to take the exemplar role.
The things you do for science.
Exactly.
And this disguise apparently seemed to work. The orangutans behaved nervously, climbing away and urinating. But
we were not getting any vocal responses, which was confusing at first. To our surprise, it was only minutes later, up to 20 minutes later actually, that the females started to engage in vocal responses. And so we immediately knew that there was something odd about the whole situation.
So why wait for minutes before making a distress call?
You wouldn't want to respond in the presence of the tiger and therefore incur the risk of an attack at that moment. On the other hand, because they could have simply remained silent forever, otherwise the infant would have never properly understood that what just happened was a dangerous event. And so they are waiting to be in safety to inform their infants about the danger.
And what does the fact that they're delaying their calls, what does this tell us about orangutans?
So far, there's this saying that animals typically communicate while being stuck in the present. What this shows us is that they actually can dissociate this and therefore communicate information about something that is not happening in the here and the now. And this is a characterizing feature of language across all the world's languages. We are constantly speaking of things that are not here or now. So this characterizes language, and yet there were so far no examples in mammals or within the primate order.
Right, so you're saying this is a kind of a really important stepping stone in the advance of language, to be able to talk about things that aren't what's right in front of us right now.
Absolutely. I think it really becomes powerful because the information that you can start actually reporting on and transmitting really expands in all directions, right? Because then you can refer to things in the past, you can refer things into the future. And so to cross this threshold is terribly important. And I think we really start to have a lot of the ingredients that we see in language coming together within one of our ancestral lineages. And now we can really start seeing how they may have interacted and therefore how could they have passed that threshold and really started something that we could potentially call a proto-language, a system that really became the forerunner of language.
That was Adrienne Lamira from St Andrews University, and that report just came out in Science Advances.
And if you'd like to find out more about any of the items that we've covered this week, the transcripts as well as all the references for the stories we've covered are on our website at nakedscientist.com/podcast.
The Naked Scientists podcast is produced in association with Spitfire, cost-effective voice, internet and IP engineering services for UK businesses. Find out how Spitfire can empower your company at spitfire.co.uk.
You're listening to The Naked Scientists with me, Chris Smith, and also with Georgia Mills. If you'd like to get in touch with the programme, it's chris@thenakedscientist.com. You can tweet at Naked Scientists. You can also find us via our Facebook page. And now, it's time for this. Is it a bird? Is it a plane? Or is it a CRISPR-inspired cyborg on steroids? We're finding out how, with the help of modern technology, humanity can potentially become superhuman.
The 12th of November sadly marked the passing of one of the biggest names in the world of superheroes. Stan Lee was the genius behind Spider-Man, the Hulk, the X-Men, and many, many more. He inspired people to look at what humanity could become, and this week we're asking if science can help us along the way. What are the ethical questions and scientific barriers that await us before we can create humanity 2.0? And we're joined by a superstar panel. We've got Barbara Sahakian, who is a neuroscientist at Cambridge University and an expert in smart drugs. We've also got Kevin Warwick, who is a robotics and cybernetics researcher at Coventry University and visiting professor at the University of Reading. He's also the world's first cyborg. And we've also been joined by Sarian Bowers, who's policy lead at Wellcome Trust Sanger Institute, and she'll be talking about genetic engineering.
Now, there are potentially three ways to enhance humanity that we're going to explore this week. They're technology, genetic engineering, but we're going to begin with drugs. Now, we all modify ourselves with drugs to some extent. Caffeine, for instance, gets us out of bed in the morning, especially if you're called Chris Smith or Georgia Mills. Also, alcohol tends to make us very chatty, and anabolic steroids are used by some people to bulk up. So, Barbara, really augmenting human type is not a new thing when it comes to drugs, but you're looking at a particular type of drugs, and in this case, these are drugs that change our brains.
That's right. So human enhancement is something that people have strived for a long time in different forms of it, as you pointed out. But cognitive enhancement is something that's really quite topical now and seems to be on the increase. So people are taking smart drugs or cognitive enhancing drugs to do better at work, get into better universities and just improve themselves.
What are the drugs in question?
So two of the most common ones are methylphenidate, also known as Ritalin, which of course is a common treatment for attention deficit hyperactivity disorder. That acts by boosting noradrenaline chemicals in the brain, noradrenaline and dopamine, which kind of fine-tune our cognition, such things as attention, problem solving, planning, learning and memory, all those sort of different forms of cognition. And then there's also modafinil, which seems to act similarly to increase noradrenaline and dopamine in the brain, but also probably affects another chemical through the balance of GABA and glutamate, so it acts on glutamate as well.
So as you say, we're tweaking brain neurochemistry
right.
to enable us to do certain things that we want to do a bit better. Therefore, if we can improve the way our brains work at certain tasks, why hasn't nature done that for us?
In a way, many times we wake up and we just feel great. We've got a good night's sleep and we get down to work and we feel energized. Our motivation is good. Maybe we're doing a task we're really looking forward to. And so we're kind of then at what we might call our optimal level of performance. But many times, of course, we're suffering from jet lag. I know you got back from Australia recently. Some people have small children who wake them up in the middle of the night. So we're traveling around the world, and a lot of people are also under stress, which impairs your cognitive performance. So even as a healthy person, you can often be performing lower than you should. But these drugs will actually improve performance in people who, for instance, are Cambridge undergraduates. So you can get improved performance in people who are not sleep deprived and who are actually very high intelligence.
All the things you've described are symptoms of an overbusy lifestyle, a burning the candle at both ends approach to life. Are we not just giving ourselves another crutch to lean on?
I couldn't agree with you more. I mean, we really have to think of this as a society where we all be pill poppers in the future just so that we can get in a bit more work, stay awake and alert for longer and be competitive with somebody else who's working alongside us and so forth. I mean, there are really great ways, such as exercise, to enhance your cognition. That really boosts your cognition. It improves your mood, and it's very good for your physical health. So really, we should be doing things like taking exercise, maybe doing a lifelong learning course or something else interesting like that.
What I'm uneasy about is that we may find ourselves in a situation with almost a two-tier society where you've got people who are chemically enhanced and they'll turn up for their exams at university having pulled all-nighters for 3 weeks beforehand, and they'll be at the top of their game because they're popping pills quite legitimately, whereas someone who takes the same approach to exams that the Athletics and Doping Association take to sport, which is that you should not chemically dope your body and we're going to ban you if you do. Those people who turn up with a clean sheet, they haven't done any of this sort of thing, are going to perform less well, not because they're less able, but they've got fewer drugs on board.
Well, that's a really good point. I mean, sometimes when I'm lecturing to students about these issues, students will come up afterwards and they say, I don't want to take these drugs, but I feel pressure put upon me, the sort of coercion to take these drugs because I can see other people passing them around in the library and I'll feel I'll be at a disadvantage if I don't take them. And we know that even a small 10% in improvement in a memory score could lead to a higher A-level grade or degree class. So we have to think about this very carefully.
It sounds like these drugs can have quite a big impact on how well someone does. But where might it go in future with scientific improvements? Like the film Limitless and Lucy, I think they pop one pill and become super Einstein straight away. Will that ever be possible, do you think?
Well, already the effects are what we call mild or moderate. So a moderate effect is really very good for a healthy person to get up to that level of improvement. So sometimes a 10 to 40% improvement. So that's really very good for these drugs that we already have, like Ritalin, methylphenidate, and modafinil. But other people are looking at sort of enhancing creativity, and they're looking at microdosing with LSD. This is going on in Silicon Valley and places. And that's another drug that's affecting the brain in different ways as well. So there are new experimentation going on, but unfortunately not with pharmaceutical companies. They're not developing too many of these new cognitive enhancing drugs, which is a shame because really my research has to do with trying to improve cognition for people with psychiatric disorders and Alzheimer's disease and brain injury.
And thinking of jobs like being a pilot, being a doctor, do you think in the future it will just be like a matter of course for these people to just take something that makes them more efficient at their jobs?
Well, we first need the long-term safety and efficacy studies in healthy people because we don't have those. But if a drug is shown to be safe and effective for a healthy person to take, it may be better than caffeine. So I did a study with Lord Aradasi at Imperial College, and he wanted to look at sleep-deprived doctors because a lot of his doctors have to operate at night. They take a lot of coffee to get the caffeine. We heard about caffeine as a booster. But the trouble is then they get a hand tremor because that's a very common side effect of caffeine. So modafinil may be a better cognitive enhancing drug and an awake alerting agent for doctors to use, but we really need those studies first. I'm really quite concerned about some of the very young people, people under 24, 25 years of age who are using these drugs because we know our brains are still in development. So there's one thing to use these drugs as an adult where your brain is fully developed, but if you're still got this, essentially the adolescent brain, which is in development, what are the effects of putting a drug into a healthy, normal developing brain?
Barbara Sahakian is staying with us throughout the programme. Thanks very much for that, Barbara. We'll return to her in just a moment. But first, someone else who puts things into his body.
We'll clarify that a bit. Yeah, so that was pharmaceuticals. But thinking about a superhero like good old Tony Stark, a.k.a. Iron Man, he's just a regular guy who uses technology to fly around and kick butt. Now, we're joined by someone who, as far as I know, didn't fly into the studio, but does hold the incredible title of the world's first cyborg. Kevin Warwick, welcome to the programme. Please explain to us, how are you a cyborg?
Well, I've had 2 implants. The first is a fairly simple one that quite a few people now have got, which is an identification implant. So with that, as I was able to move around my building and the computer could recognise where I was, and it opened doors for me, switched on lights, said hello, things like that. So that was the first one. But I think what Barbara's been talking about is the chemical aspect, particularly of the human brain and how you can affect them. But of course, the brain brain is electrochemical, and I'm really looking at the electrical side of things.
And is it true you technologically linked yourself to another person as well?
Well, who happened to be my wife, yes. Yeah, we wanted to show all sorts of different things. You were talking earlier about communication, and what we did, my wife had electrodes pushed in her nervous system, and we linked our nervous systems together. So every time she closed her hand, my brain got a pulse. So it was like a telegraphic communication directly between our nervous systems. And clearly what we're looking at is the future of communication is linking not just nervous systems together, but brains together. So we'll be able to communicate not in this antiquated way that, surely now we can start moving on as humans, enhance ourselves and start communicating electrically, directly, brain to brain.
Man, that sounds quite romantic, but also potentially very irritating.
But I mean, I experienced ultrasonic input. What we're looking at, humans sense the world in a very limited way. We miss most of what's going on around us because we don't sense it. But we can do in the future. And with the technology I was using, I was able to sense ultrasonics, which is like a distance, like a bat senses the world. And our brains are brilliant. They adapt. They can take on new signals in that way.
So as well as Tony Stark, you're also Batman as well.
But for real. I mean, Tony Stark and Batman are mere, characters. This is doing it for real. Science has gone further than some of these characters, I think. And one other example. I went to Columbia University in the US. We plugged my nervous system into the internet and linked back to a robot hand, which was in England, in Reading. What I actually did, I moved my hand, but my brain signals, which we were picking up off my nervous system, were sent across the internet to move the robot hand, which was in England. And then when the hand gripped an object, signals were sent back from the fingertips in England to stimulate my nervous system in New York. So I could feel how much force the hand was applying on another continent.
That's madness. But what about if you're linking yourself up with technology? What about someone hacking your nervous system? Does that worry you at all?
Well, it didn't from the research point of view. I mean, we did, my nervous system actually had an IP address for that particular experiment, but we had security in the sense that we didn't tell anybody what we were doing. I mean, clearly, if we're looking ahead for this in a general sense, clearly then security would be a much, much more important thing. So we wouldn't want to allow hacking as we might do into our bank accounts and things like that nowadays.
So what other kind of ways might you be able to enhance yourself with technology?
Well, I think if we're looking at brain implants, then clearly you can link your brain directly with an artificial intelligence system and gain all sorts of things from that. I mean, we know human memory is not that wonderful, particularly as you get older. We've got all sorts of problems with it. But computer memory, of course, can be absolutely fantastic, extremely accurate and so on. So the possibility of, simply not remembering anything in your own brain, outsourcing the whole lot to a much more accurate but instantly accessible source, why not?
I'm interested to hear how far you'd go in theory, Kevin. I mean, you're talking about sort of mental enhancements. What about something like a superpowered bionic arm and things like that? Does that sound all right to you as well?
Well, in a way, I've already had that. So, that's something I've experienced in terms of connecting from my own nervous system to a robot arm. From that, though, I mean, when you start connecting the nervous system and your brain up to the outside world, it doesn't have to be arms and legs and so on that you connect on. You can have buildings, you can have vehicles. So your body, which can be separate from your brain, as long as it's connected via the nervous system, via a network, your body can be whatever you want it to be, whatever the network takes you to.
What's next on your wish list, Kevin? Just wondering, what you might like to connect up next.
For me, the big one is communicating brain to brain. I mean, I would love to take part in the first thought communication experiment. It's a very risky business because switching the switch to connect two brains together, what exactly is going to happen there? But I just have a hunch. I believe that we are going to be able to communicate just by thinking, and I would love to be one of the first people to test that out.
Be really interested to hear what you do next, Kevin. Thank you very much, and do stick around. We'll be coming back to you later in the programme.
Now take a listen to this.
This is a syringe. This will modify my muscle genes to give me bigger muscles. Ooh, didn't actually hurt that much. Oh, hurts a lot more going in. All right, there we go.
We have with us Sarin Bowers, who's the policy lead at the Wellcome Trust's Sanger Institute. What's actually going on there?
This is a man who decided to inject himself with CRISPR, which is this genome editing tool, in order to enhance his muscle function. I think it was pretty much a bit of a gimmick, to be honest, but it certainly attracted some attention. And I think it really effectively demonstrated how easy it is to do this technology or use this technology yourself.
And what actually is the technology and how does it work?
CRISPR it's actually a bacterial system. It's the latest in a long line of genome editing tools. So scientists have been able to change the DNA of organisms for many years, really since the 70s. But this discovery of this bacterial system has really sort of been a game changer. So it allows scientists to very, very accurately target a gene, make the change very precisely, and it's really easy to use as well.
Is it reliable? Does it go wrong?
It is reliable, but it also does go wrong. So there is a big discussion about off-target effects. So when you're supposed to be targeting gene A, how many times it accidentally hits another gene, and that seems to vary depending on what exactly it is you're trying to do.
So what could we do with it?
The options are sort of almost limitless, but scientists at the moment are really interested in treating disease. So we've already had some patients that have had this done to them. So there was Layla, who was an 11-month-old baby who had leukemia, this was actually a sort of precursor to CRISPR, but it was very much the same idea. And they treated her leukemia with that, and she's still in remission, which is great. We've also had some patients who were actually edited to be more resistant to the HIV infection that they had.
Now, we've discussed diseases and fixing those, but this programme is very much about how we could enhance what we've got already. So starting with a healthy state, making it better. So how might this technology be employed to do that?
Well, we've obviously already seen someone trying to enhance their muscles. In theory, there are all sorts of things, so intelligence and cognitive ability, so that potentially is an area where people are interested. There's obviously super strength. There is a lot of sort of fantasy speculation out there about what you can do. I think probably a little bit still very much fantasy.
Because it's tricky, isn't it? Because something like a single gene trait, that I can see in theory how you could change. But intelligence and things like height, as far as I'm aware, there's a massive, massive interaction between loads of different genes that we don't even really understand yet. So do you think we'll ever be able to sort of boost intelligence?
On the intelligence point, I think it depends what you mean. So there was this recent article about IQ and the ability to identify the genes involved in IQ and effectively predict someone's IQ and therefore do a screening of embryos. IQ is not a particularly great measurement of anything very much. Donald Trump claims to have an IQ of 160. That doesn't necessarily say very much. So I think, yes, you can make changes, but whether it's actually the change that you really want is probably very much open to debate. You're absolutely right about this complexity in the genetic networks. You mentioned height, for example. I mean, height, not only does it have a genetic component, but it also has an environmental component as well. So these are really complex systems that we're talking about.
And say the science does get there and you can have your wish list for either yourself or perhaps your kids. What about the ethics? What do you think will be allowed and what won't be?
Currently, it is completely illegal to edit embryos for reproductive purposes, and that's across Europe, and much of the world has that kind of legislation as well, and it's certainly the case in the UK. It may be considered ethical in future, I think, to do that kind of editing.
Is not one exception to this mitochondrial editing? Because when a person has a mitochondrial disease, we know that's a genetic condition, and there are now techniques which are being used a bit like CRISPR to alter the mitochondria that are in those affected cells so that they don't carry that particular abnormality.
With mitochondrial disorder, you're not actually editing, you're completely replacing the mitochondria with healthy mitochondria. And this is legal in the UK, and the first treatments have just been licensed for it. And it is a very, very specific use case. So there's a very small number of people who will benefit from this technology, and the case is very obvious for those people. And I think most people feel very sympathetic towards that, and so it is ethical. In terms of enhancement, I think Kevin actually raises quite an interesting discussion, and I think there is going to be an ongoing debate about what is acceptable and what's not.
earlier in the programme I mentioned Spider-Man. So he was bitten by a radioactive spider and had all the powers of a spider and a man. So could you take a gene from an animal and put it in a human?
So that's probably not that easy to do. There have been a few examples, not in humans, I have to say, but you sort of occasionally see these stories. So I think there was one a while ago about fluorescent cats where they put this green fluorescent protein from jellyfish into cats. It was a proof of principle study, really, and there is a scientific use for that kind of technology, although glowing kittens is probably not the actual output that you want. In terms of humans, I think it's going to be a little bit more complicated than that. I think there are many men out there who'd like to look like Tobey Maguire. I don't think we're going to get there just yet, and they're certainly not going to be swinging from building to building.
Probably be more Jeff Goldblum from The Fly, wouldn't it?
Do you think there's also a risk with this? We don't know what sits in the gene pool, because there may well be traits in the gene pool that at face value look initially disadvantageous, but then when considered in other circumstances may carry a benefit. And I'm thinking, for instance, the cystic fibrosis gene. We now understand that carriers of that are at lower risk of catching diseases like typhoid. And if we were to screen out everybody who's a carrier of cystic fibrosis, we would potentially not have that resistance against typhoid. It's one example. I mean, there are many. But is that not a danger? If we go thinking, well, we want all these traits, actually we may be losing some very important ones.
I think that's absolutely right. Genes and genetics are a very complicated network. And so while we can identify one gene as having an impact on something, if you start changing it, it may have downstream effects that we aren't currently aware of. And so I think while there will be some cases where the trade-off is worth it, in terms of enhancement, I think it's always going to be too complicated for that. You're always going to have these side effects that you don't particularly want.
Brilliant. We started with the clip of that person injecting themselves with CRISPR. Maybe not the best idea they ever had. But Kevin, I'd like to bring you back in here because you experimented on yourself, essentially. Were you nervous about that? Like, how did you feel about trying something out for the first time on your own body?
Well, I think it's quite dangerous. And one of the reasons for trying it on myself was in case something went wrong. If it goes right, of course, people say everyone knew you'd be able to do this. If it goes wrong, then people say, what an idiot, getting it wrong like that. But also I wanted to experience it for myself. That was important as well.
Are you comfortable with this, Barbara?
Well, it's always a worry when people are experimenting on themselves. I mean, obviously, Kevin took the procedure to go through ethics and so forth, but a lot of people who are, essentially putting themselves online doing these things don't go through those sorts of procedures. And also, I mean, I find, with people, for instance, buying these cognitive enhancing or smart drugs, they're buying them over the internet. You really don't know what you're buying. It could be anything.
Sage advice. But the reason I ask you that is because people are using these drugs. That's because they regard them as pretty much de rigueur. Well, once things start to become like what Kevin's doing, a bit more de rigueur, people will just start doing that too, won't they? So we'll end up with mental implants, drug implants, and we'll be doing CRISPR in our spare time.
Well, I'm all for safe enhancement. But on the other hand, as we discussed, one also wants to look at what the drivers are for society. I mean, if it's, a lot of philosophers and people like Kevin want to self-enhance themselves to see where the limits are and to carry on scientific experiments. And some people, like John Harris at Manchester, thinks that we should all be enhancing ourselves because it's our duty for the next generation that we try to do the best we can and we make newer inventions and we make the place a better world. But I think that there are some great ways that are just safer and perhaps more traditional, like exercise, that is incredibly good for you. And people sort of override that in terms of just a quick fix with a pill.
Well, we've spent a while discussing the future of superhumans, but perhaps they already walk among us. Rowan Hooper is the managing editor of New Scientist, and he's just written a book called Superhuman, about the people who've become the best of the best. So what's their secret, and how do we all become a little bit super? I caught up with him earlier this week.
I've met people who are superhuman in a range of different traits. So from intelligence to running ability to longevity to even happiness. So why don't you pick me a trait and I'll talk about someone who's at the peak of human potential for one of those.
Well, as a science podcast, I'm going to have to go with intelligence for the first one.
Okay, so it's really interesting. How do you think about intelligence? You could think, well, I'll pick the person with the highest IQ, but I wanted to try and think of different kinds of intelligence. So I went to meet Hilary Mantel. So she's one of our greatest living novelists. And I wanted to ask her, what is it about your ability, your talent? Where did it come from? And when did you first notice it? And I did the same for a Nobel Prize winner, a scientist, Paul Nurse, and a chess grandmaster as well, who'd been in the world top 10. And for all of them, I asked, where does your skill come from? And interestingly, they all noticed something about themselves from a very young age. So the chess grandmaster, he could have started to understand numbers before he could understand letters. Hilary Mantel didn't speak until she was 2.5, and her parents were getting a bit freaked out about it. And then she started speaking like an adult, and she'd just been biding her time, and suddenly this skill of language seemed to be there from a very early age with her. And with Paul Nurse, there was this incredible sense of curiosity that he's just nurtured and built on his whole life. And he always felt that there was something a bit different about him compared to other people in his family. And so that this kind of superhuman intelligence in different forms was there from an early age, but they all nurtured it and built it up.
And what about some of the physical traits you encountered?
I met some endurance runners, people who've done some absolutely mind-blowing feats of endurance. So I met a young woman called Petra Kasparova. This year she won, it's not even a marathon, it's a 6-day race where you literally run for 6 days, round and round a track in New York.
Do you get to sleep?
You do get to sleep, but it's up to you when and how long you sleep for. So you have a little tent in the middle of the track. You can crawl off, go into the tent, and then just get up and carry on running. So they basically have a few hours sleep now and again. And the winner is the person who's run the furthest in 6 days. And she ran 370 miles. So it's more than 14 marathons. Yeah, absolutely extraordinary. And you'd walk past her on the street and you wouldn't think there's a superhuman. And this is what I think is amazing about her. She's not like a superhuman like we might think of from the comics, but she has this incredible inner fire and kind of meditative power that makes her carry on. She just keeps going.
I think I'd have spent the entire 6 days in the tent. So, yeah, what really can you nail down makes someone a superhuman?
They all tend to have a sense of optimism and a can-do attitude and a kind of dedication to what they do. And they love what they do as well. So for the rest of us trying to think, how can I be a bit better in my life? A really good thing is not to do things you don't really love. And it sounds stupid, but I think a lot of us do things we don't love. We might stay in jobs we don't love, or play an instrument or do a sport that we don't really love. It doesn't suit us. So I think the take-home message really is to find something you actually really like doing. Because all the people I met who'd got to the top of the game, who were the best in the world at their particular trait or ability, they really love what they're doing. And I think that's a great take-home message.
Right, so yeah, an average Joe like me, if I wanted to, I don't know, become superpowered, just do something I love?
Yeah, do something you love. Okay, look, let's set a limit here. You know, you might not become superhuman, but you'll certainly get better at something. It's the same in athletics. The people who get gold medals, often they've tried many different sports at an early age before they find the one that they eventually go on to become a medalist for. The ones who don't get medals tended to be ones who specialised earlier in a sport and didn't try other sports as they were growing up and training. So try different things until you find the one that's right for you.
Would you say that there is also a genetic component? I don't think I'd ever be good at the high jump, for example.
Well, yeah, I mean, for something like the high jump, tall people are better, and there's a big genetic component to height. But more generally, there absolutely is a genetic component to expertise. You're going to need a genetic leg up. And what's also interesting is it turns out from genetic studies we've found now that the amount people practice something, that itself is genetic. We all know people who've got a sort of real fire in their belly, a real dedication. They get up in the morning, start doing something, or they learn something and they don't give up. That kind of attitude, that itself seems to have a genetic component.
And given that there is this genetic component, and given that humanity is constantly pushing ourselves, doing all these crazy things, running for 6 days, do you think that we're, as a species, getting more super, if that makes sense?
Yeah, I do. We are getting better. If you look at, say, what the average person could do 100 or 200 years ago, we're better now. we're getting incrementally better. And I think there's a lot more potential left in us. There's a lot more things we can do, a lot more. So I think that's what's really interesting. We're by far from the end of fulfilling our potential as a species. There's loads more we can do.
So no need for CRISPR tech or anything like that. Just do what you love and become a superhuman in your own special way. Thank you so much to all of our superstar guests this week. That was Rowan Hooper, Kevin Warwick, Barbara Sahakian and Sarian Bowers.
And to finish this week, it's time for Question of the Week. Over to Eva Higginbotham, who's been having a whirl at this one.
Hello, Naked Scientist team. My name is Daniel. I'm from Norwich. My question to the team is, why jet engines, the type you see on almost every commercial aeroplane with the large forward-facing fan blades, are not used on the aeroplanes that are sent to investigate hurricanes? These still use propellers, albeit that these may be driven in some way by a jet engine. Is it that propeller engines are safer in high-stress situations?
Well, flying into a hurricane certainly sounds stressful. We've had this excellent suggestion from Evan AU on our forum, who said, could a propeller plane, with its lower speed, be more manoeuvrable for flying into the eye of a hurricane? But what do the experts think? Dr. Anna Young of the Whittle Laboratory at the University of Cambridge specialises in gas turbine aerodynamics.
Well, there are two different types of aircraft engine. The smallest light aircraft have a propeller powered by piston engines, much like the engine in your car. The problem with these engines is that they can't fly very high or very fast. So most planes are powered by turbine engines, and these are what we call jet engines. The jet engine then has a couple of different types. Turboprops, where the turbine engine powers a propeller, and turbofans, where the turbine powers a fan. You'd normally see a turbofan on a large passenger plane, and a turboprop on a smaller plane. So both turboprops and turbofans get their power from a turbine. It's just, in the case of a turboprop, it powers a propeller in front of the engine, and in the turbofan, it powers a fan inside the engine.
So, what about planes used for research into hurricanes? Do they use turboprops or turbofans?
A lot of the planes used for hurricane measurements have turboprop engines, so they do have jet engines, they just don't have turbofan engines. The reason turboprops are used on smaller planes is simply that they're more efficient at lower flight speeds. You don't need to fly so fast when you're just doing a short domestic flight, and that's the same when you're popping into your local hurricane. If you're flying through a hurricane, the advantage of flying slower is that you can spend longer inside the hurricane taking measurements. There is also a safety advantage in that flying more slowly is that bit safer when you're being bashed about by the wind.
But there's also a second benefit of using a turboprop engine in a really gusty environment like a hurricane.
And that is that the propulsion from the propeller is independent of the power created by the turbine engine. This is important because really big gusts or side winds can cause the propeller on a turboprop or the fan in the turbofan to stall. So mainly, hurricane scientists use turboprops because they're better suited for the kind of flight speeds they want, but there is also a potential safety advantage.
There you have it. No need to get in a spin. Next time, we'll be fetching the answer to this question from Dottie.
If you look at a Great Dane and then you look at a Chihuahua, they are so different. Do we know if a Great Dane meeting a Chihuahua recognises it as another dog?
Well, let's hope we're not barking up the wrong tree with that one. If you know the answer, get in touch. It's chris@thenakedscientist.com. You can also write on our forum, nakedscientist.com/forum, or tweet @nakedscientists.
Now, before we leave you for this week, we'd just like to bring up our donor drive. We're trying to raise £50,000 by Christmas to support the programme and its hard-working staff.
So far, we've got to £3,000 or thereabouts, and we'd like to say a very big thank you to some special people. They are Paul, Peter, David, Walter, Simon, Daniel, Jeff, Bruce, Don and Rick. They were our biggest donors so far. Thank you very much indeed. We're really grateful.
And as a special treat, we'll send one lucky person who donates this week a copy of Rowan Hooper's new book, Superhuman. To get in on the action, you need to go to thenakedscientist.com/donate. And don't forget to click in the box to comment on the donor wall. Perhaps you could tell us what superpower you'd like to have. That's nakedscientist.com/donate. Thanks very much.
And that's it for this week. Thank you very much for listening. Georgia put the programme together. And do join us next time when we're going to be getting our teeth into the science of gnashers. That's right, it's a show all about teeth. The Naked Scientist comes to you from Cambridge University and it's supported by the EPSRC and Rolls-Royce. I'm Chris Smith. Thanks for listening, and until next time, goodbye.